This is problem 13 in 2024 AMC 10A. Two transformations are said to commute if applying the first followed by the second gives the same result as applying the second followed by the first. Consider the following four transformations of the coordinate plane. A translation 2 units to the right, a 90-degree rotation counterclockwise about the origin, a reflection across the x-axis, and a dilation centered at the origin with a scale factor of 2. Of the 6 pairs of direct transformations from this list, how many commute? So to solve this problem, let's just list all these 6 pairs of distinct transformations out and see which ones work. Because there's only 6 pairs, so it's not going to take that long. And right now, can't really think of a better solution. So yeah. And okay, so firstly, the case 1 here is a translation 2 units to the right. So I'm just going to write translation and followed by a 90-degree rotation. So followed by rotation. So let's see if the translation and rotation actions commute. So we can use a random point as a reference on the coordinate plane. We can use a random point. For example, we can use point 2, 3. So this is point 2, 3, and if you the first thing you can do is translate it 2 units to the right. If you translate it 2 units to the right, so this is 2, 3. If you translate it 2 units to the right, it'll become 4, 3, right? And then you're going to rotate it 90 degrees counterclockwise around the origin. Counterclockwise is this way. So 90 degrees counterclockwise is going to be, you draw a line like this and you rotate this point. You rotate and then you draw a line perpendicular to this line here like that, and these two distances are the same. And then yeah, you rotate. So this is gonna be, so basically a simple trick to remember is if you rotate 90 degrees counterclockwise, you just flip the coordinates and you add a negative to you add a negative to the x coordinate after you flip. So this is -3 because this is 3, so it turns to -3 and you have 4. So -3, 4, and 4, 3, right? Okay, so let's see if the same thing happens. So the end point here is -3, 4 if you start at 2, 3. So let's see if the same thing happens if you first rotate and then translate. So it's this point over here, and you first rotate, so like that, and you rotate. So this is -3, and so this should be lower. So this is 2 and -3, right? And then you translate 2 units to the right. If you translate 2 units to the right, the coordinates will be -1 and 2. Now the coordinates here are -3 and 4. The coordinates here are -1 and 2. So they're clearly not the same. And so this means that these two are not commute. These two actions are not commute. So the second action would, so the second pair of transformation would be translation and reflection. Translation 2 units to the right and reflection across the x-axis. So again, we can use the same thing as an example, but this time we're not going to draw the graph. It's kind of a waste of time, I guess. In the actual test, you can draw the graph if you're really confused, but after you get the idea, you don't have to keep drawing the graph because it's time consuming. So if you get the idea, then you can just use the coordinates. If you don't get the idea though, you can draw the graph a few more times until you get the idea. So let's start with point 2, 3 again. If you translate first, translation, if you move it 2 units to the right, you'll end up at 4, 3, because if you move it 2 units to the right, the x coordinate plus adds 2. And then you reflect it across the x-axis. If you reflect a point across the x-axis, so you can use this as a reference. If you reflect this across the x-axis, the y coordinate becomes negative. So now it's 4, -3. It's going to be here. It's 4, -3, right? So now let's see. Now if you reflect first, though, you have 2, -3. and then you can translate it 2 units to the right, so now it's 4, negative 3. So for this point, which is a random point, this thing works, and since point 2, 3 doesn't have much like special properties that make this work, and if you try other points, it also works, like these two are commute, then you can assume that the two actions are commute. So this actually works, and the first one doesn't. And then for the third pair of transformation, you have translation and dilation. Dilation is basically you, like for example, you have 2, 3, and you dilate it at the center at the origin with a scale factor of 2. So you draw this line and you scale this line up by 2, but one of its endpoints is still at the origin. So this means that if you translate first, this will become 4, 3. If you dilate, you scale up by 2, and the center is at the origin, and center at the origin basically means you multiply the coordinates by 2, so it's 8, 6. And if you dilate first, you have 8, 6, if you dilate first, you have 4, 6. And then now you translate, you have 6, 6. These two coordinates aren't the same, so this is not commute. So we know that the answer is not 5, because out of the 6 pairs of distinct transformations, at least 2 don't work. So yeah. So 5 isn't the answer, and now we can also look at, we have rotation and reflection. If we have rotation and reflection, we can see we start at 2, 3. Say we rotate counterclockwise by 90 degrees, we end up at like negative 3, 2, right? So you end up at negative 3, 2. So you flip the coordinates, and then you take the negative of the flipped x-axis, and you reflect this across the x-axis. So the y-coordinate becomes negative, so you have negative 3, negative 2. And you have 2, 3, can reflect this across the y-axis first, so you have 2, negative 3. You rotate it 90 degrees counterclockwise, so you flip the two, coordinates, so it's negative 3, 2, and then you take the opposite of the x-coordinate, so it's 3, 2. So these two coordinates are not the same, so this is not right. So the answer is not 4, because out of the 6 pairs of distinct transformations, at least 3 don't work, so there's only 3 left. For the 5th pair, we have rotation and then dilation. So if you use 2.23, after rotation it's at negative 3, 2. For dilation it's at negative 6, 4. And then after rotation you have, so if you dilate first though, you have 4, 6. And then you rotate, you have negative 6, 4. So this actually works. So the answer isn't 1, because at least 2 pairs of solutions work. So whether it's B or C, it all comes down to the last pair of distinct transformations. So you have reflection and dilation. So for reflection and dilation, you start at 2, 3. If you reflect first, you have 2, negative 3, and then you dilate, you have 4, negative 6. If you dilate first, you have 4, 6, and then you reflect, you have 4, negative 6, so this works. So the answer is, if you count the number of ticks, there's 3 ticks in total, so the answer is 3.